Alright, let's see if I can solve this problem. I tried it a couple times a year ago, wasn't able to do it. So let's see if I'm able to do it now. Okay, let's see. I might consider handling this case first. I really might consider that. But the case when we have 99 and the case when we have 9 is sort of different. It's sort of different because if we have 9, then we add 1, right? So we might add 1 to it, and we get 10, which is greater than 9. What exactly does this 10 mean for us then? 10 is greater than 9. Well, if we were to do essentially what we were going to do before, which is, alright, well, we get a number greater than 9, we take that position, set it equal to 0, and we maybe hold a carry. So now our answer, our current answer is just, literally just a 0. And then at the end, we might be able to unshift a 1 so that we get 1, 0. Let's try doing that. Let's try doing that first. So just a simple case, right? So in the case that you know, we're given a 9, then we can check well, before we do that, actually, slow down a little bit. Let's think about this case. So 1, 2, 3, and I'm gonna think about this case, 9, 9, right after. Let's see where we go from there. Well, from here, we add 1 to least significant digit. So to least significant digit. So we add that to 3. We get 4, which is not greater. Which is not greater than 9. So keep 1, 2, 4. Carry is equal to 0. No unshifting. Okay. So what about this case? So here, let's do this. Yeah. So that's greater than 9. So digits. So it wouldn't be digit 0, but digits 2 is equal to 0. So we get 990. And then see digits 1. So we add 1 to least significant digit, which is now this guy, right? And you get 10, which is greater than 9 again. So you do digits 1 equals 0. So now you're looking at this. Add 1 to least significant digit. You get 10, which is greater than 9. And you get digits 0 equals 0. Alright. So now you have 0, 0, 0. You have a carry of 1. So then you can unshift 1, array unshift 1, 1,000. So that should be okay. Let's check potentially another case that we might need to analyze. What if we get something like, let's analyze this case, 199, okay? So you want to check carry of 1, probably outside of loop, sort of like the last thing you do. So you add 1 to least significant digit, you get 10, which is greater than 9. So digits 2 equals 0. Now you're looking at 190. Add 1 to least significant digit, you get 10, greater than 9. Digits 1 equals 0. Boom, so you have 100, right? And then once you're done with that, you see, okay, while you see 9s, keep looping inner loop, and then you add carry to 1. So really what you're doing here then is, so maybe we need to think about it differently actually, because what you're actually doing, so in this case you add 1, here you're adding 1, but here you're actually adding the carry. You're not adding 1 anymore. So that's what's important to realize. Our carry is 1, right? But you're adding carry. I think that's an important distinction, because you're not just like continuously adding 1. You add 1 once. You're adding 1 to the end. And then what you keep adding to each other digit is the carry value, which is 1, but it's different. It's different than the initial add 1 that we're doing. I think it's important mentally to understand that that's what's happening. And I think it'll help me when solving the solution. So we're going to add carry to this 1 here. So why is that important? So we add carry here, and we get 2, which is less than 9. So now you break loop. Now you break loop. Break loop because carry plus digit I is less than 9. Yeah, so that's a solid foundation. And now, and note that at this point, our pointer should be at 0 or at the start. So we can start a pointer from the end to the start, which shouldn't be too bad. We can let I equal digits dot length minus 1, and then maybe create a carry that starts at 0, right? And we're going to essentially loop while. So what do we want to do? What do we want to do first? The first thing we want to do is maybe we let digit total equal digits I, so that element, so if that's a 9, we let, so I plus 1. You say while digit total is greater than 9, we want to keep doing something. So what we can do is we can say if digit total is greater than 9, carry is equal to 1. So while digit total, and then what we want to do also is, so we want to decrement I, and then we might say while. So I mean, I have a better idea than to do this. We can just say while I is greater than or equal to 0, so it'll iterate first, and then we can calculate, instead of calculating up here, what we can do is we can calculate, we're guaranteed that the length is going to be at least 1, so we might be able to just go down here and calculate that. So we have digit total equal to digits I plus 1. So in this case, you get 10, right? And you say, well, if digit total is greater than 9, then I want to set digits I. So I want to do two things. I want to set digits I equal to 0 and set my carry equal to 1. Okay, so we keep carrying that on out. And then we're going to decrement I, and then we're going to see that it's going to break out here. And then we can say if carry exists, then we can do digits unshift the carry. So this should work for which case? So this should work for this case. Okay. Now for 123, you get your digit total, and you get digits I, and you add 1. Now, if it's not greater than 9, then quite literally, all we have to do is say that, so we can say that digits I is equal to digit total and break. So we say that 3 is going to be equal to the 3 plus 1. That's our initial add. So this is our initial, since this is our initial add, I get the feeling that we don't want to continuously do this over and over again. I just have that feeling because of what I said. Like, what we'll be adding continuously is the carry. We only want to add once, really. So that leads me to question whether or not we even want to get into this loop. For example, if we look at digits I, and it's less than 9, and it's less than 9, we can just return, actually here, let's do this. We can say digits I going to equal digit total, and then return digits. So that eliminates the need to do that. And then do we even need this? Well, okay, so let's see. So for these cases, it's just going to end up incrementing our digits. So it's going to increment this to be 4, and then return, and increment this to be 2, and then return digits, right? So it works in all these cases, and in the case that it's 9, where it's not less than, so we're gonna run this loop. We're gonna say, all right, well, if the total, we want this to be digit total. So if digit total is less than 9, so it's 0 to 8, then when we add 1, we're totally fine. When we do that, we're totally fine. So yeah, so if digit total is greater than 9, so it's 10, 11, whatever, then we have our carry. So let's look at, so it should work for this case, if digit, and then, turn digits This is an O of n operation. I think this is going to be O of n. And then this, it should work for that case. And then in this case, so, you know, we loop. The only thing we would need to do is we need to, you know, continuously calculate our digit total. So I guess we can do it at the end. It doesn't really matter. It's fine. Because initially, if we get 10, it's greater than 9. We do the carry thing. That's fine. We decrement. Now we're looking at this 9. And then we calculate the total here. That's 10. So next loop, that's 10. Turns this into 0. Our carry is 1 again. And then decrement to 9. And digits total is equal to, so then you get 10. And that's the final loop, really. And digits I is equal to 0, turns that into 0, carry 1, and it turns that into 1,000. Yeah, so that's fine. So if there's a carry, we always want to unshift. But in this case, you know, this is the case that's going to throw me off, because, okay, so we say, all right, well, we have 10, so we can turn that into 0, carry equal to 1. So here's the thing, Interesting. So here's what I'm doing. I'm saying, okay, well, let's, you know, we see that this is greater than 9, so we're going to turn this to 0. We're going to say our carry is going to be equal to 1. Okay, so then we decrement, and then we add, so we decrement, so we're looking here, we're going to add this by the carry, which is 1. Yeah, and then so we get a 0, and then we say our carry is 0, right? And then we loop again, and we see that this 1, so digit total, so 10, 0, 0, carry 1, add digit total, so digit total is 2. Digit total is equal to 2. So I think it'll work for this case, but now I'm questioning whether or not it's going to work for the other case. So that's set carry equal to 0. Let's see what happens if the stop process is even remotely on point. Does that give me 200? That's the thing. That is exactly the thing. Okay. Now this is the big one. Does it still work for this case? Okay, this is a very interesting problem, very intricate. Let's see what it might fail on. Oh, Okay. Well, that is the solution. And that's how you know you've improved by leak coding over time, is because I don't know how close I was to the answer back then, but that wasn't too bad. This is improvement. This is very much an improvement. I am surprised. I've done how many problems since then? About 119 problems since that time. So there is definitely some improvement there. Yeah, that's good. That's good. Where was I before? I had something like that. I don't really. I'll be honest. This is kind of hard to read, but output was 10.9. Yeah, I'm having a difficult time reading that, if I'm being honest with you, but well, here you go. I had a feeling, I can't really tell if I like this problem or not. I know it requires a fair bit of planning. I can't really tell if I enjoyed solving this. Like, I can see why it has a lot of dislikes. I'm mostly indifferent to it, so I'm not gonna like or dislike it, but well, there you go.